Hello, this is Britt Caswell with another example video. In this video, I'm covering example 2 from section 4-5 in the SavvasRealize Algebra 1 textbook. So in this example, we are learning how to write a system of inequalities from a graph. Now, when I go to do this, I am going to be using the slope-intercept form of a line, which is y equals mx plus b. So please don't forget that the m here is our slope that we're looking for, and our b is our y-intercept. So let's go ahead and let's give that a shot. So I'm going to start with this blue line and its shading. So I know I have a y, so I need to identify my m, which is slope. So if you notice, from one point to the next on this blue line, I'm falling by 1 and running by 1. So my slope is a -1. Now when I write this in an equation, I don't tend to write the 1 in front of an x because it's implied. So I just wrote -x. Then I need to figure out my b value, which is my y-intercept. So this blue line is crossing the y-axis at +4. So I'm going to put a +4. Now I need to figure out my inequality symbol. So if you notice, the shading on this line is above the line. So that means that y has to be greater than all the rest of the equation. And because it's a solid line, I'm going to put the equal to bar underneath it. Let's go ahead and try the orange line. So again, we have our y equals mx plus b, so I need to figure out my slope and my y-intercept. Now I see my y-intercept here at 3, so I'm going to put a +3 on here. And my slope from one point to the next looks like it's rising by 2 and running by 1. So that's a slope of 2. The shading on this orange line looks like it's beneath the line. So I'm going to say y is less than all that stuff. And because it's a dotted line, I'm just going to leave it as the less than symbol and not put the equal to marker. So this is my system that goes with that graph. Let's go ahead and let's try another one. So starting with the blue one, I'm going to look for my y-intercept. If you notice, this is at 8, where it's 4 here. So these boxes are counting by 2's. So my y-intercept here is at -2. Now my slope is still going up one box, over one box, so I still have a slope of 1 here. Alright, you could think of it as rising 2 and running 2, so like m equals 2 over 2, but that simplifies to a 1 slope as well. And I don't have to put the 1 in front of the x because it's implied. Now the shading on the blue is going underneath the line, so that means that y is less than all of this stuff. And then my line is solid, so I need to put the equal to bar here. Alright, now checking out this next one. So my y-intercept is up here, which looks like it's at 2, so I'm going to put a +2. And then I'm looking for my crosshairs for my slope. So from one point to the next, it looks like I'm rising by 3 and running by 1. So I have a slope of 3. Now the shading for this orange line is above the orange line. So I'm going to say that y is greater than all that stuff. And then because the orange line is solid, I'm going to say it's greater than or equal to. So let's go ahead and just try one more. So starting with the blue line, I have a y-intercept here. And again, it goes up to 4 right away, so each of these boxes is worth 2. So my y-intercept is at -4. And in terms of slope, I'm rising by 2 and running by 4. So my slope is 2 over 4, which is 1/2. Now the shading for this line is below it, so that means that y is less than all this stuff. And my line is solid, so it could be less than or equal to. Alright, now for the orange one. So on the orange one, my y-intercept is at 0. So I'm not going to add anything on here. It's just going to say is some kind of number times x. So then I need to identify my slope. Now my slope's going downhill, so whatever it is going to be negative. And it looks like it's falling by 2 and running by 1. So it's negative 2 over 1, which is just negative 2. Now the shading for this line is above the orange line, so that means that y is greater than all that stuff. And because it's a dotted line, it's just y is greater than, it cannot be equal to. So there's our system there. So that is how you write a system of inequalities from a graph. Until next time.